Hello, young people. It's Mrs. Rains. I am recording this to try to get you a little more information on limiting reactants or reagents. It's called both, so I wanted to give you both names just in case so you could see them. So we're going to start off right here where we left off. So we had a question, and I'm getting rid of my face right now. Okay. So we had a question. If we had 3.42 grams of potassium dichromate added to 10 milliliters of ethanol with a density of 0.789 grams per milliliter, how much carbon dioxide was made? I think I forgot that one. Hang on just a second. Let me add it. How many liters of CO2 will be made? Now I can tell you, you can tell if you need a limiting reactant issue if they give you two quantities that are reactants. If they give you two quantities that are reactants, then it is required of you to figure out which quantity will run out first. If it's not limiting reagent, they will say something like, I added such and such to excess. And if they tell you they add such and such to excess, that really means that all you're looking at is the one thing that you know about. In this case, because we know about two of them, we have to look a little deeper into our situation here. So the first step is to balance the redox equation. And we did this in class. So I have the balanced equation written down here that we did in class. 16H plus aqueous plus 2 dichromate ions aqueous plus 1 mole of ethanol liquid plus 4 chromium 3 plus ions aqueous plus 2 carbon dioxide gas moles plus 11 water moles in liquid form. So the first step that I need to do is I need to transfer everything that I have, the information that I have, into moles. So I have the first one, the most obvious one, is the one that we started, and that is 3.42 grams of potassium dichromate. And I know that I need to find moles of the dichromate. Oops, sorry. I can't write today. Moles of the dichromate ion. So I know that that's where I'm headed and I need to go, because the only thing that I can do is compare moles to moles. Remember, all of these numbers, this 16 and this 2 and this 4, 2, and 11 here, are all ratios of moles. So because I have grams, I'm going to start with grams of potassium dichromate, and I'm going to change that into moles of potassium dichromate. Okay, so now grams are gone. So now moles of potassium dichromate have to go away, and I'm looking for moles of the dichromate ion. Okay, so now I go back and put my numbers in. Well, it's always, when the substances are the same, moles are always 1. So moles are always 1 here. In this case, the grams we get from the periodic table, and it happens to be 294.2. Over here, because they're different, they could be different numbers than 1. But we know in 1 mole of the solid compound potassium dichromate, there's only 1 dichromate ion, so it's 1 mole to 1 mole. So we can see grams are canceling out, moles are canceling out, and when we calculate, we get an answer of 0.0116 moles of dichromate ion. Is that good so far? Okay, so the next step is to calculate the ethanol. Well, we know the density, but it's grams per milliliter. If you see a unit that is double unit, it's a derived unit, grams per milliliter, moles per liter, anything like that, then you're going to kind of think, oh, that could be a conversion factor. So the only thing that I have about the ethanol is this 10 milliliters. So that's where I'm starting. I'm starting with 10 ml of C2H5OH, and I want to get to moles of C2H5OH. So once again, I'm going to convert notice as I'm doing this, I am putting no numbers in first. I am using simply the units to guide me. Okay, I put a 10 over here only because that was my given quantity. That's it. So I know milliliters have to go away. So I'm going to put milliliters of ethanol on the bottom because I know that has to go away. Okay, where do I have milliliters? Well, I have milliliters in the density, so I know milliliters are related to grams of ethanol from the density, which means now I have to get rid of grams of ethanol. And I want moles of ethanol. So in reality, the problem is not hard, but we have to use density as a conversion factor. So I'm going to put 0.789 grams in 1 milliliter of solution. I know that there is 1 mole because this is the same substance, and I know it happens to be 46.08, 2 carbons, 6 hydrogens, and 1 oxygen. So when I calculate through, milliliters are now gone, grams are now gone, and now we have moles. So when I calculate, I get 0.717 moles of ethanol. So far so good. We've gotten our moles. Now we need to do a little bit of a comparison. So we are going to use something that in equilibrium speak we call an ice table. So I stands for the initial, or I'm going to say the before reaction. Okay. C stands for the change being made, and E is the after reaction quantity. So I know that I have right now 0.0116 moles of the dichromate ion. I also know that I have 0.171 moles of the ethanol. In my product side, I have 0 moles of the dichromate ion, chromate ion, chromate 3+ ion, 0 moles of carbon dioxide, and 0 moles of water. It's the beginning. It's before the reaction has occurred, so there is none of that there. So what's going to change? Well, I use the stoichiometry. I use the numbers in here to determine what's going to happen. So if I lose, I'm going to lose 2x moles of this. X meaning some number that is lost. Why 2? Because the coefficient is 2. Over here, ethanol is going to lose X. So what happens on the product side? Are we losing or are we gaining? Yeah, we're gaining. So we're going to gain 4X of the chromium 3 ion. We're going to gain 2X of the carbon dioxide. And we're going to gain 11X of the water. So after the reaction, the concentration, or the number of moles, I should say, the number of moles of the substances should be 0.0116 minus 2x, 0.171 minus x, this should be plus 4x, this should be plus 2x moles, and this should be plus 11x moles. So we have now quantities that we can start looking at. We know that one of these two quantities needs to run out. So the next step is to set these two equations, this one and this one, equal to 0. So that's where we go. We set these two equations equal to 0. So I'm going to say the next step is we set equations equal to 0. Because we know one of them needs to run out, and we want to find the quantity that we would need to run out. Well, this one's pretty easy. If we set this equal to 0, in this particular case, let me change my color of my pen. Okay, if we want this to run out, we know that X is going to have to be 0.71 or 171 moles. Okay, over here this one's a little bit more complicated. It's a little bit more complicated. So we're going to look at that one as well. Okay, so this one we are going to do 0.0116. 6 minus 2x is equal to 0. And when we solve for x by rearranging, we get that x is equal to 0.0058. Now this is how we know which one is actually the limiting. The one that is the smaller of the two numbers here is the limiting. And if we think about that, that makes utter sense. So if this is the limiting, then that would mean I'd need twice as much as this substance. So if this is the limiting reactant, if ethanol is limiting, then that means I would need almost 0.3. We would need almost 0.3 moles of the dichromate ion. We don't have that. But we do have enough of this. So when I'm comparing this number to my original number, right, and looking at the change, I'm looking at it from that perspective. So let's say that again, okay, because I know this is confusing. So I'm looking at this number right here, and I want to compare this number to the amount that I have right here. This number is much smaller than that number. This is how much of the ethanol that I would use. And if I were making, or if I needed the chromium to react to all of that, I would need double this according to what I'm seeing here. I don't have double. If I look over here, this is the amount of X. This number is smaller than this one. So this number is less than that number, and this number is greater than that number. And so the one that is less than the other number is the limiting reactant. So in this case, we now know that the dichromate ion is the limiting. And that means every other calculation I do from this point forward has to start with the moles of the dichromate ion. All right? So let's move forward again. So again, we're doing a comparison to see how many moles need to be used up. What is this X value? And then when I get that X value, I need to compare that X value to what I had in the other substance. The one that is less than the other substance is the limiting. The one that is greater than the other substance is not. It is going to be in excess. Okay, and I can actually figure out what that excess is now that I know X, but we'll get there in just a little bit. Okay, so here we go. So now that we know that, we are going to take this 0.0116 moles of the dichromate, and we want to find liters of sorry about that, I just moved myself. Liters of CO2. Okay, so that's where we are right now, liters of CO2. So how do we go about doing that? Well, again, we are going to use our units to guide us. So here I have moles of dichromate. I've got to get to CO2. So that's where I'm starting. I'm putting moles of dichromate on the bottom. That means I'm going to put moles of CO2 on the top. So moles of dichromate are gone. Now I have moles of CO2, but I want liters, and I did say at STP, and that's a clue, because at STP we know there's a relationship between moles of a gas and liters of that gas, and at STP there's 1 mole to 22.4 liters. So where do I get these numbers? Yeah, they come from the original balanced equation. There were 2 moles of dichromate ions and 2 moles of carbon dioxide ions in the balanced equation. So yeah, that's a 1-to-1 relationship. I know that, but notice I still put 2 and 2 because I don't want to be confused. I want to be straightforward. I want to know what's happening. So here we go. Moles of dichromate ion cancel out, moles of carbon dioxide cancel out, and we end up getting that there is 0.260 liters of carbon dioxide, or 260 milliliters. And that is your final answer. Okay? That is your final answer. Now, another thing that can be asked here is, how much of the excess reagent is left over? So if we take a step back for just a second, I'm flipping back to the next slide. If we take a step back, we know the answer to that question. We use this after the reaction equation right here, right? And we subtract what our X was that was used up. Our X that was used up here is 0.0058 moles. So if I come back to my slide here, I know that I had 0.171 moles of ethanol. I know that I used 0.0058 moles of the ethanol, which means that I am going to have a total of, I'm going to have 0.1652 moles of ethanol left. So if I go back and I want to know how many milliliters of ethanol that is, well, that's a pretty simple task. What I have to do is do the backwards planning of what I did before. So I take moles of ethanol and change it to grams of ethanol. And then I take the grams of ethanol and change it to milliliters of ethanol. Okay, and all these numbers come from where we are, so or from our problem. So we have 46.08. Remember this from the other problem. Moles are gone, and now I have 0.789 grams in 1 milliliter. Grams are gone. So when I start calculating, I get an answer of 9.65 milliliters of the ethanol. I did not use much ethanol at all here. Very little, in fact. Okay? So this is the process of finding limiting reactant. I want you to practice it just a little bit. I want you to think about it. Remember the process. There will be a question on your quiz. However, that question on your quiz will not be as heavily weighted as everything else. I want to see that you're trying that process. If you're trying that process, you're going to get points. The other parts of the quiz are going to be a little bit more detailed. Okay? So thank you, and I will talk to you all on Monday.